All right, welcome back, fifth graders, to another lesson on area. This time we are going to switch gears and find the area of a right triangle. Right up here, looking at that for our title. And in looking at that, you might look to the right-hand side, just beyond our title, and see that we have a pink rectangle sitting there, and you might say, Mr. Mace, that's not a triangle, that is a rectangle. Well, that should be another large clue, guys, that we are still going to use that formula for finding the area of a rectangle. So area equals base times height, and that is going to be our key. That's going to be our lead-in to help us establish the formula for finding the area of a triangle. It's going to be, again, just like the parallelogram, very much linked together. Not exactly the same as it was with the parallelogram, but very, very close. So, using that formula, again, to try to find the answer to question number 1 here, which says, what is the area of this rectangle? It says we have a base of 8 and a height of 4. So as I look over here and plug that into my formula, area equals base times height. That means it's going to be base of 8, height of 4. So my area is going to equal 32. And again, remembering to label this correctly, guys, centimeters squared or square centimeters. All right, just again, remember that we are, with area, we're trying to determine how many squares will fill up the inside of a two-dimensional shape. Now the next step, they're asking us to simply draw a diagonal line from one of the corners to the opposite corner of the rectangle. So I'm going to pick this upper left-hand corner here, and I'm going to draw as straight a line as I can down to that corner. And hopefully you notice that we have now created two separate and hopefully identical shapes. So as we look at this, you should be able to see that we have created one bottom triangle here, and 2, a top triangle here, and that those triangles look to be, we might not be exact if I didn't draw it perfectly, but very close or similar in size. So as we read into the question a little further, it says, what is the area of each triangle? Well, the area of both triangles has to equal 32, guys, because we haven't changed the rectangle. The rectangle is still there. The dimensions are still the same. All I've done is I've drawn an extra line through the middle of that, hopefully, hint, hint, dividing it in half. So I would bet that the area for each of those triangles would be half of 32. So if we look at that, what is half of 32? One way to do and find half is to simply divide it into two equal groups. So 32 divided by 2. Go through my long division. No, it's been a while since we've done that, guys, but we'll go through the long division just to show you that process again. And we should realize that half of 32 is 16. So we are looking at each triangle is 16 centimeters squared. And guys, you're going to find that no matter what, with rectangles and squares, if you find the area of the whole shape, and you choose to draw a diagonal, you have cut that in half and you've created two equal triangles. All right? So as we look at that now, we should be able to start piecing together a formula in our head. Okay? It's going to be half of a base times a height. Half of the area of a rectangle. So the first thing to do is to find the area of the rectangle. So I'm just going to go through 3 through 5 here to find the actual area of the rectangle first. Okay? So I know in the directions it says what is the area of each shaded right triangle shown below, but before we do that, I want to show you how we're getting to that. All right, so if we look at number 3 here, we've got a base of 5 and a height of 2. So the rectangle area is 10 centimeters squared, or square centimeters. Okay, a little bit better M there, not quite. Okay, but then if I look at just half of that rectangle, I've got to cut 10 in half, and so that makes then the area of that triangle half of 10, which is 5 centimeters squared. All right. Same thing for the next one. Now this next one is a square. How do we know it's a square? Because we've got the same numbers on the base and the height, which means its opposite sides are also equal, which gives us 4 equal sides. And so we're going to prove here that, again, it doesn't matter whether it's a rectangle or a square, as long as it is a quadrilateral, a parallelogram, so to speak, with 4 right angles, we are able to easily use this same formula. So the area of the entire rectangle or square at this point is 8 times 8, or 64 square. In this case, I just changed the label to meters, which then means the triangle is going to be half of that. Again, only looking for the green shaded portion of that, which is half of 64 or 32 square meters. Pretty straightforward, right? Okay, last one that we're going to do together here. And now this one's a little bit harder simply because the numbers are a little bit larger. All right, so as we go across here, we see that we have a base of 16 and a height of 14. Okay, I'm going to let you probably pull out a calculator to try to figure that one out. It is a 2-digit times 2-digit problem, and we're not judging you on your multiplication at this point. All right, hopefully when you plug that into your calculator, you found that the area of the rectangle, guys, is 224, in this case, square inches. So if we try to find the area of that triangle, we have to divide that in half. Well, if I divide 224 in half or divide it by 2, I end up with 112 square inches. All right? So if I were to come out and write an actual formula down and show you what that is going to be, 5th graders, there are 2 ways I can write the area of a triangle. Area of a triangle equals half of the base times the height. Notice the parentheses. I'm going to find the base and the height first, and then I'm going to divide that in half or multiply it by a half. Okay? And then I'm going to, another way I could write it is the area of a triangle is also base times height divided by 2. These 2 things mean the exact same thing. Now, if you remember back to parallelograms, guys, we talked about the fact that we are looking at true height. We are not looking at angled lines, and with a right triangle they give us that, even if that base isn't on the bottom. So as you look at questions 6 through 8 here very quickly, guys, you can see that 6 is very traditional. You can see that the number they give us for the base and the straight line and the perpendicular square corner is right there at the bottom. So our base is the bottom and our height is going straight up from that. And so when we find that 12 times 12 is 144, and we find half of that, which gets us to be 72, all right, 72 square inches, okay, 12 times 12 divided by 2 would get us to 72. Again, if you want to try that in your calculator, go ahead and do that. But you can see that that's a really easy base to determine. But what happens with these next 2? Which of those numbers is the base and which is the height? Well, again, when they only give you 2 numbers, it's pretty easy. But what happens if they decided to write a 17 feet here? Am I now looking at 17 being the base because it's the bottom number, or it's the one on the bottom side of the triangle? No, we have to identify, guys, the square corner, and the base and the height are always the 2 sides that are touching that square corner, that 90-degree angle. So as we look at number 7 here, guys, we are looking at a base of 7 or a base of 14, however you want to look at it, and then a height of the opposite. All right? So as we multiply those and divide it by 2, okay, we end up with an answer of 49 square feet. Remembering to divide by 2. That is the key to this. Now, you might say, well, we're dealing with triangles, Mr. Mace. Why is our label still squares? Okay, well, it does not matter what you are measuring area for, guys. Even the area for a circle. If we're looking for what is the area of this circle, you're still going to label it square units. We are still trying to cover that with squares on the inside of a 2-dimensional shape. So the label will not change. All right? Thank you very much, 5th graders, for your time. There is an exit ticket to try out to make sure you understand the concept. And again, as every other lesson before, if you have any questions, please send me a message via Schoology, and we can set up a meeting and try to figure it out.